What is going on with Saturn? Scientists have been looking at this planet for decades, and they still can't answer one very basic question. What's in its center? Is it a solid ball of rock like Earth's core, or does it just sort of fade away into a giant cloud of hydrogen? We actually don't know because we've never seen it. And what makes matters more difficult is that there are good arguments for both possibilities. So let's get fuzzy about that. This is our channel. We tend to think of planets as having a solid, well-defined center. After all, that's what we experience here on Earth. When you punch something, you punch something. You feel resistance. There is a center to that thing. But scientists don't know if that's true for Saturn. It might not have a hard, distinct core at all. Instead, it might have a so-called fuzzy core that gradually mixes with the hydrogen around it. That would make Saturn unlike any other body in the solar system that we've ever seen. Now, let's take a step back. How do scientists even figure out what's inside a planet? They can't exactly crack it open and take a look. Well, fortunately, we do have another way. We listen to it. The way you listen to a planet is by measuring how seismic waves move through it. Seismic waves are created by planetary scale impacts such as Saturn's many moonquakes. These waves travel through the interior of the planet, reflecting and refracting along the way until they reach the surface where they are picked up by listening devices such as seismometers. The catch is you have to know what kind of waves you're listening for, which means you need to have some idea of what you're expecting to hear. So scientists turn to computer models to simulate how different kinds of seismic waves would travel through different kinds of planetary interiors. Then they compare those models to real seismic data. One key factor that influences how waves move through a planet is density. The denser the material, the faster the wave travels through it. If we're expecting a solid core, then we would expect seismic waves to speed up once they got to that core because they'd be moving through a denser material. But what if the core isn't solid? In that case, we would expect the seismic waves to slow down once they reached the fuzzy core because they'd be moving through a less dense medium. So in 2010, scientists looked at data from the Cassini spacecraft, which had detected seismic waves on Saturn by listening for the moon's vibrations as it orbited the planet. And they concluded that Saturn had a solid core because the seismic waves seemed to speed up when they hit the center of the planet. But in 2021, a different group of scientists reanalyzed the same data and concluded that Saturn had a fuzzy core. They said that the waves didn't speed up. They just changed direction more abruptly, and it's not just the core. There's disagreement over whether Saturn is even a separate thing from its atmosphere. We usually think of atmospheres as being pretty clearly separated from the rest of a planet. But the boundary between atmosphere and planet gets blurrier the farther out you go. Eventually, you get to the point where the stuff in the planet's atmosphere starts getting into the stuff that makes up the rest of the planet. And the deeper the material goes, the higher the pressure becomes. At some point, the pressure is high enough to cause chemical reactions to occur that hadn't been happening before. For example, it's believed that under sufficient pressure, molecular hydrogen can become metallic. Metallic hydrogen has unpaired electrons, and that makes it electrically conductive, hence metallic. Scientists used to think that Saturn was big enough that its atmosphere would eventually become metallic, but not so massive that it would collapse under its own gravity. But in 2019, scientists presented evidence that metallic hydrogen had already been found in the atmosphere of Jupiter and Neptune. That meant that Saturn could be the only gas giant in the solar system without a metallic hydrogen layer. And if it didn't have that extra barrier between its atmosphere and its planet, that could explain why it's lost so much mass over time. The amount of mass that a planet retains depends on its mass in the first place, its composition, and how fast it rotates. A fast rotation will pull a planet a bit wider at the equator, and that makes it easier for some of the planet's atmosphere to escape into space. Now, Saturn rotates fast, which would normally make sense considering it's not as massive as Jupiter, which has a similar composition and doesn't spin nearly as fast. But if there were a metallic hydrogen layer, it would be harder for the atmosphere to escape, meaning that Saturn should have retained more mass. So maybe it doesn't have that layer because its core is fuzzy. In fact, some scientists think that the very act of retaining its atmosphere over billions of years is evidence that Saturn does have a solid core. They say that if it didn't, then its atmosphere would have long ago dissipated into space. And while scientists argue over whether Saturn has a core, they're also trying to decide whether it has a gigantic alien ocean, too. If you think knowing whether Saturn has a core would help us understand whether it has an ocean, you are right. But it's not quite as straightforward as that. It turns out that we've already concluded that Saturn probably has an ocean. It's just that we don't know if it's made of water or liquid metal. Back in 2016, scientists reported evidence of a salty ocean beneath the clouds of Saturn's largest moon, Titan. Titan is the only moon in the solar system known to have a substantial atmosphere, and it is the only place besides Earth that we know has stable bodies of liquid on its surface. But that doesn't mean that Saturn itself doesn't have an ocean. In 2013, scientists announced that they had found strong evidence that there was a liquid ocean under Saturn's clouds. They based their argument on what they called an unexpected decrease in the planet's gravitational field strength. Their thinking was that if the planet was perfectly homogeneous, then the gravitational field would drop off smoothly as the spacecraft moved closer to the planet. But instead, the measurements revealed a little bump in the gravitational field, which would be caused by an abrupt increase in mass near the planet's surface. And that could only be explained by a big C. But 5 years later, scientists came up with a different explanation. They cited computer models that showed how the gravitational field would be affected by convection currents in the planet's atmosphere. Convection happens when warmer, less dense fluid rises and cooler, denser fluid sinks. And it turns out that these currents could mimic the signature of an ocean. Still, scientists aren't sure what's going on with Saturn's core, and it's possible that it has something to do with the planet's rings. After all, they're pretty spectacular. And scientists believe that the rings may have formed from ice and rock that was blasted off of the icy moon Enceladus, which has its own subsurface ocean. Whatever the rings are made of, they're intermediate in complexity. The simpler rings are opaque and only a few miles wide. The more complex rings are transparent and hundreds of miles wide. And some scientists speculate that they may have formed after Saturn's core started to solidify. As the core grew, it would have pulled itself together, causing the ring material to collapse and form a thin shell. That means that the most direct evidence for Saturn's core may come not from studying its seismic waves or its atmosphere, but from looking at its rings. The problem is that scientists have a lot more questions than answers when it comes to rings. Like, are they even held together by gravity? Or do they rely on some other force to keep them in shape? Turns out we don't know. There are so many things we don't know about Saturn. It may not have a solid core, and it may not have a clear boundary between its atmosphere and its planet, and it may have an ocean of some kind. But you know what we do know? It is not a planet that we have ever figured out. It's a fascinating gas giant that continues to hold mysteries that we can only hope to solve. Speaking of holding mysteries, we're holding a mystery box giveaway on our social media accounts. To enter, follow our channel and send a DM telling us what you would put in your own mystery box. We'll contact the winner directly. The contest closes on October. You can find all the details on our social media accounts. Thanks for watching this episode of SCI Show Space. If you would like to give us some love, you can head over to our support page. We've got some neat rewards for our top-tier supporters.